In this video, I'm going to discuss on basics of electronics. Remember, we discussed that electricity created the second industrial revolution. We cannot do anything without electricity. In basic electronics, there are two essential concepts we need to learn in order to understand the working nature of electronic devices. That is electricity and conductors. Now, there are different types of energy. When something moves, we say it generates kinetic energy. Everything is made of atoms. These atoms have protons, electrons, and neutrons. These electrons can be used to transfer energy from one place to another. This energy is called electricity. It's a form of energy which is carried by free-flowing electrons, especially inside conductors. Conductors are the materials which support the transportation of electricity. Most of the conductors are metals such as copper. Since this energy is transferred by free-flowing electrons in these materials, actually good conductors have abundant amount of free electrons. This is why only some materials become good conductors. When electrical energy is transported from one place to another, we can recognize current. We give the term circuit for any closed systems with a power source and a device consuming that power. Here you can see a battery and a bulb creating a simple circuit. When the electrons move from negative end of the battery to the positive end, we say that a current is generated. Current is measured by amperes and marked by the letter A. Usually, a 1 ampere is lot of current, and the current in small circuits we make are measured in milliamperes. Then let's take a look at the voltage. Before moving into the voltage, let me give you a very popular analogy used to understand the principles of electricity. It's the water analogy. I already described to you about a simple circuit. So the same circuit works very similar to a water tank with a pipe system. The electron flow is similar to the way the water flow due to the pressure created by the water tank on the pipeline. Similarly, there's a pressure created by the power source of the circuit, which is known as voltage. It helps to push the electrons from one end to the other, creating a current flow. It is also known as the difference between the electron pressure in two ends, which makes the electrons to flow when a path is provided by a circuit. Voltage is measured by volts. Now let's take a look at a simple example. When the height of the water level is increased, the flow of water is also increased. The water is projected to a longer distance. Similarly, when the number of batteries are increased, the brightness of the bulb is increased. Then let's discuss about another very important concept in electronics: resistance. Resistance is known as the disturbance to the electron flow in a conductor. Why we really have to talk about resistance? This is because resistance is the factor which decides the flow of electrons, and the current and voltage are closely related to that. Resistance is measured by ohms, which is normally marked with Greek letter omega. You can see in this example that the flow changes when the disturbance is changed with this regulator to the pipeline. When there's less resistance, the water flow travels a longer distance. In the same manner, when the number of resistors are increased, the brightness of the bulb is decreased. Resistors are kind of electronic components with known resistance values. We will discuss in detail about them in the next lesson. As I mentioned earlier, voltage, current, and resistance are very closely related. This is calculated using Ohm's law. It is in fact one of the most important equations in electronics. The Ohm's law states that V equals IR. V is the voltage, I is the current, and R is the resistance. Therefore, in any circuit, voltage is equal to the product of current and resistance. To understand this more simply, let's look at an example. Let's say there is a circuit made by connecting a bulb and a resistor with a battery using copper wires. If the voltage of the battery is 3 volts and the resistance is 100 ohms, we can find the current by dividing 3 by 100. This gives us 0.03 amperes or 30 milliamperes. See, it's very simple, and yet Ohm's law is one of the most widely used equations in electronics. In this lesson, we discussed on electricity, voltage, current, resistance and Ohm's law. During the next video, I'm going to discuss on electronic components with you.